We are now just a few minutes away from our 11:29 p.m. launch time in Baikonur, and SkyTerra 1 will launch aboard an ILS Proton rocket in about 3 minutes. The Proton is specifically designed to launch in most weather conditions, such as extreme hot or cold. Harsh upper-level winds are really the only weather condition that could cause a delay in Proton flight. Now, Russ, can you give us a weather update for Baikonur?
Certainly, Jennifer. The weather conditions at the site are favorable for launch and skies are perfectly clear. Currently, the weather readings at the Baikonur Cosmodrome indicate that we are within range limits for liftoff. At last check, we had a liftoff temperature of 6 degrees Celsius, which equates to 43 degrees Fahrenheit. Ground winds are out of the southeast at 3 to 6 meters per second, and the upper winds are within allowable limits at all altitudes. So again, weather conditions are very good, and currently we are go for launch.
All right, we are a little over 2 minutes away from launch. Tell us about some of the final preparations that are taking place as we speak.
Jennifer, the launch team is now verifying a variety of things: electrical connections, battery charges, and final systems checks between the rocket and the payload. They will also conduct one final check on the weather. About 10 minutes ago, the spacecraft ground crew signaled that it was go for launch. This was followed by a similar signal at T-minus 5 minutes from the Proton's first 3 booster stages. Then, at T-minus 2 minutes, the Proton-M upper stage is pulled by the automatic sequencer to give the last go command prior to liftoff at T0. Right now, the vehicle appears to be in positive condition for liftoff.
All right, sounds good. Thank you, Russ. Well, all right, I want to point out now to our viewers, and for the first few minutes after liftoff, we're going to be watching the end from Baikonur in real time. As the Proton travels easterly downrange, however, our viewers are going to notice some time lags between the actual flight and the display of those events, and even in the commentary. The reason behind this delay is that as Proton follows its pre-programmed flight path, it will pass out of range of the Baikonur receiving stations. At this point, signals are received by stations downrange and transmitted back to Baikonur. This may cause some short delays. Now, Russ Prytula, ILS Program Director, is going to take us through the final pre-launch stages and then through liftoff. Russ?
Well, we're just about 45 seconds before liftoff. You're looking at a beautiful picture of the launch vehicle on the pad, Pad 39, Baikonur. And today's launch is a result of an accumulation of a lot of hard work and long hours. And everyone on the launch team is eagerly awaiting the liftoff. Teams are in their places in the launch bunker, control rooms, ground stations, and communication centers. The final go for launch polling is being completed. Again, just a few seconds away. Looks like about 15 seconds left. So this is what it all comes down to: 2 years worth of effort on a lot of people's parts, and tensions are running high, excitement's running high. We are just seconds away.
2, 1.
And there it is. Ignition start. We have liftoff of an ILS Proton rocket from the Baikonur Cosmodrome in Kazakhstan with the SkyTerra 1 satellite on board. Gorgeous sight, as it is every time you get a chance to see it. At about 10 seconds after liftoff, the rocket does a roll maneuver and will soon experience maximum dynamic pressure, or max Q. Max Q is the maximum aerodynamic load on the vehicle. It corresponds to about Mach 1.6 and occurs at 1 minute, 2 seconds after liftoff. Everything seems to be proceeding nominally as the vehicle heads in an easterly direction with a flight azimuth of about 61.3 degrees. 50 seconds into the mission, still getting a real good view under the clear skies. The vehicle is pitching over, so it starts to look more like a point of light as it heads downrange. And we are just at a minute and 2 seconds, so we're just now passing through the point of maximum dynamic pressure. We're coming up on the first stage's separation from the second stage that is set to occur at 2 minutes into the flight. We're just now at a minute and 31 seconds into the flight, still getting a good view of the vehicle heading downrange. It's a beautiful night, and On a night like this, you often can visually tell when the first stage has separated from the second stage, so just seconds away from that nominal event. Okay, we're just past 2 minutes into the flight, so we're past the time when the event nominally occurs. Just going to wait for the confirmation of that event coming from Baikonur. You're seeing an animation of what should be happening at this point in the flight, just waiting for the confirmation of Baikonur. Again, there's a little bit of a lag in order to get that information back from Kazakhstan. Okay, and we have confirmation of a good separation between the first and second stages. The second stage engines actually ignite while still attached to the first stage, and the exhaust from those engines escapes through the open grid work between those stages. And it looks like we have a signal of ignition on all 4 second stage engines. They will burn for a total of about 3 minutes and 27 seconds. Just over 3 minutes into the flight, and we just saw a projection of the timeline of those activities, back to an animation of the vehicle heading downrange. The next key mission milestone will be stage 2-3 separation at L plus 5 minutes and 27 seconds. 19 seconds later, the payload fairing will jettison.
When you